Here we have an interesting question. We have been given a string or rather a rope which has a mass m and a total length L. A pulse is started at the bottom of the string. We need to find out the velocity of pulse at distance x from the bottom and also the time taken by it to reach the top. Now, an important thing to realize here is that the tension throughout the rope will not be constant because it has mass, due to which the velocity of the pulse will be different at different portions of the string, because the formula for velocity of a pulse is equal to v is equal to root over t upon mu, where mu is the mass per unit length of the string and t is the tension in the string in that part. Therefore, because of variable tension throughout the string, we will have variable velocities throughout the string. So, let us check what happens at distance x. For finding out the tension, this is a rope. We cut the rope at distance x from the bottom. The mass of this portion of the rope is balanced by the tension on the top of the rope. Now the mass of this rope is m upon L, that is the mass per unit length, into the length of this part, that is x. This is the mass. Therefore the gravitational force acting here is mxg upon L. This is balanced by the tension at height x. Therefore the tension is equal to mxg upon L. Therefore the velocity of the pulse when it reaches that portion will be equal to v is equal to root over mxg upon L into mu. Mu is mass per unit length of the string, which is constant, and that is equal to m upon L. So this becomes equal to v is equal to root over xg. So we get the answer for our first part, that is the velocity of pulse at distance x from the bottom comes out to be equal to v is equal to root over xg. Now we need to find out the time taken by it to reach the top. For this part, we just need to remember that v is equal to root xg and the velocity is variable in terms of x. Now the velocity is variable is equal to root over xg. Now at height x, when it covers the displacement dx, this will take a time v, dx is equal to v dt. Therefore dx is equal to root over xg into dt. We can bring this here to get dx upon root x is equal to root g into dt. We will integrate this from 0 to t, we will integrate this from x is equal to 0 to L to get 2 times root x 0 to L is equal to root g into t. Therefore 2 root over L upon g is equal to the time taken by the pulse to reach the top. So we get the answer for the second part as 2 times root over L upon g. There was another way which you could have used, or rather you should have noticed to solve the question really very fast, that v is equal to root over xg. Therefore v square is equal to xg. Now this is something like v square is equal to u square plus 2ax. 2v dv by dx is equal to g. Therefore v dv by dx, that is the acceleration, it comes out to be equal to g by 2 is equal to the acceleration of the pulse. Now initial velocity of the pulse was 0. By this formula, acceleration is equal to g by 2. Displacement is equal to L. Therefore L is equal to half at square, because ut is 0, g by 2 into t square. Therefore t is equal to 2 times root over L upon g. So by this method also, you find out the final answer for the time taken to be equal to 2 times root over L upon g.